In this video, I'm going to talk about JavaScript iterables. My brother and I are reading a book called Eloquent JavaScript, and I'm going to explain iterables by how the author of the book explained it. Before we dive into what iterables are, we need to understand about two things. Number one, what are interfaces? And number two, what are symbols in JavaScript? Let's understand what an interface means with the help of the for each method available on all arrays in JavaScript. We know that all arrays, for example, if I have this array, all arrays have a for each method on top of it, which is inherited from array.prototype dot for each for all of the arrays. So I can use that method on this array to do whatever I want with each of the elements. For time being, I'm going to just log them as such. We also know that all of the arrays have a length property on it, which describes the number of elements that are there in that array. What is exciting about for each method is that it is also an interface. For each method will work for any JavaScript object, which follows these two rules. Number one, the object has a length property. And number two, the object has numbers for some of the property names. Let's understand what am I talking about. Let's say we have an object defined by object initializer syntax, which are these two brackets, and we are defining some properties on it. One of them is length. We have manually defined it to be do. It could be anything. And the next couple of properties are 0 and 1, which are numbers, and they have some values. In this case, these couple of strings. What we are now going to do is use the array.prototype dot for each function and call it for this object. And we are going to pass in the callback for the for each as a second argument. I'm going to do the same thing. I'm going to log the elements. And surprisingly, what we are going to see is that it is going to log A and B as if it was an array. But remember what we talked about. For each works for any JavaScript object which follows these two rules. Number one, it has a length property. Number two, it has some properties which are numbers and they could have any values. Those are the properties which should be iterated over and which we can do something about. So these two rules are the interface on top of which for each is made or made to function in a way that it does. The behavior where a piece of code works with values of different shapes, as long as they support the interface it expects, is called polymorphism. Another example of an interface in polymorphism is the for of loop. For of loop loops over several kind of data structures and not just arrays or strings. For of expects a value or a data structure to expose a specific interface, which arrays and strings do expose by default, which means that we can add this interface to any JavaScript object and the for loop would be able to iterate over that object. Understand this interface and the definition and rules of it, we need to learn what symbols are. Symbol was a new primitive that was introduced in 2015. Symbol is an inbuilt object whose constructor returns a primitive value called symbol. In this example, we have a value that we are capturing from whatever gets returned from calling the symbol constructor. Note that I'm not calling it with the new keyword. It is just called just like function. The type of sim here would be that of a symbol. To make a symbol value, you just call this symbol function with an optional string, which is the description argument for the symbol. The description argument is helpful for debugging purposes and doesn't play any role in the value of the symbol. Let's just define another symbol value, now just passing in some helpful description so that whenever we try to debug sim2, we are able to see that it is associated with that description. That is the only use case for the description. The unique characteristic of a symbol or a symbol value is that it is guaranteed to be unique. No two created symbols can be the same. So for example, if I do something like this, I write a symbol with some description and write another symbol with the same description, they are bound to be false because they are unique values in itself. And the description doesn't play any role whatsoever in the value of the symbol. It is just something that we can use to debug symbols. The interface needed to provide a generic functionality to any object to become iterable requires that we are able to set a unique property on the object such that it cannot be overridden by any user-defined mechanism. Since a symbol guarantees unique value, they are a perfect fit for this use case. Symbols can easily sit as properties, just like numbers and strings, of objects without disturbing any other property or its value. In this piece of code, we are making a symbol and capturing its value in a length variable, and we are setting a prototype on the array with the property name of that of the value of the symbol and setting it to 0. If we console log its length property, we see that the value is 2 as it is supposed to be. But if we log an array's prototype value whose property is involved, then it will be 0. So as you can see that they both can coexist because the value of length is not actually a string length property, but it is a unique value whose type is symbol. And similar is the case for any other data type or data structure or any other kind of type of object that is there in JavaScript. In this example, very similar to the one that we had seen before, here we are setting a new property of the name of the symbol's value, and we are setting it to this number. And when we log my trip's length, the length will be 2 because the value of the property string length is 2. But if we log the value of the property, which is the symbol, this one, it will be the value that is explicitly set on that symbol property, which is this number in our case. We are finally ready to understand iterator interface. The object given to the for of loop is called an iterable. An iterable follows these rules which make the iterator interface. Number 1, the object has a method with property symbol.iterator. Symbol.iterator is itself a symbol, an inbuilt symbol just given to us in a handy form to be used specifically to make iterables. Number 2, the method on symbol iterator property, when called, returns an object. This object has a next method that returns the next result. This object with the next method on it is called the iterator object. Number 3, that result should be an object with the properties value and done. If done is true, it means that the iteration is over and the value is the iterated value for any particular iteration. Since arrays and strings in JavaScript are inbuilt iterators, they have all the above rules already in them, built in. Let's see that in action for arrays. So for example, we have an array of these numbers. All the arrays would have method of the property symbol iterator. And if we check it out, we can see that it is an inbuilt function. And if we call this, we will get our iterator object. And let's store that in this variable called iterator object. On this iterator object, as per the definition, we will have the next method, which when called will give the value of the next object that we have in this form. We will get the value in the value key, and we will get to know if the iteration is done. If the done's value is true, right now it is not, it is false, which means that if we call it again, it will get us the next value, and the iteration is still not done up until the point where the value is undefined and the iteration is done and there are no more values in the array to be iterated. For the final part of this tutorial, let us create a custom iterator In our case, we will create a linked list and we will make it iterable. Linked list is a linear collection of data elements whose order is not given by their physical placement in memory, like arrays do. Instead, each element points to the next. It is a data structure consisting of a collection of nodes which together represent a sequence. In its most basic form, each node contains data and a reference, in other words, a link to the next node in sequence. We can depict it like this. We have a starting node which has a value, in this case 4, and it links to the next node whose value is 7, and then so on and so forth. It will have a link to the next node with a value and a link to the next node with a value of 61 here, until there are no more nodes to follow. Let's create a simple linked list. I've used TypeScript, but it will not matter for this explanation. This class creates a linked list by creating two properties on the object that it will create on its instantiation: value and rest. This object is the representation of a node in the linked list that we saw in the diagram just a while back. We have a handy method which gives the total number of nodes in the linked list. Will not be using it. It was just in the book, so I included it. Then we have a static method called fromArray, which takes an array and converts it into a linked list. It does so by iterating over the array, starting from the last element. So this is the last element, that is the first iteration. And then keeping a track of the result, which will become the next node. For example, we start with a value of 5 for an array of 1, 2, 3, 4, 5. Then we create a linked list with its rest property set to null. So this will be 5, and because the result is null, this will be null. So we get a node with value 5 and its next linking node to be null. And then we will iterate over this loop. In the second iteration, we move on to number 4 and we create another linked list with the value 4, because the iteration value is, and the rest as the linked list that we had created before in the first iteration, which was the node with the value 5 and the rest value null. We keep moving until we have a linked list that looks something like this. So I am just using that static method and passing in this array, and the linked list that will be created, I'm going to log it here. So I'm just going to run the code. You can see that this linked list looks like the first node has value 1 and then it has a value rest, which points to another node with value 2, and then rest, which points to another value, so on and so forth, until we reach 5, whose next node reference is null. To make this object, which represents the linked list, an iterable, such that when we try to loop over it, we are able to get all the values of each node in the linked list, we have to add symbol.iterator method for this object. The simplest way to do it is to add a symbol.iterator class method on the class itself, so that whenever the object is created by instantiation of this class, it gets added to the object's prototype automatically. We are defining the symbol.iterator method, and it will return an iterator object. Remember that iterator object is nothing but an object which has a next method, calling which should give us the next value of iteration. So let's make the iterator object returned from symbol.iterator method. I have created a separate function or method called getIterator object, which I'm going to return from here. The only thing that is getting passed to it is the linked list itself. The linked list object that is passed to the getIterator method is used to set this linked list for iteration instance property that we have defined here and initialized to null. Linked list for iterations function is to unload the next node from the previous node, We will see this in action in a second. Get iterator object returns the iterator object, which has the next method, which is responsible for returning the next value of iteration. So we are checking here that if linked list for iteration property instances value is null, it means that our iteration is done, the value is undefined, the property done should be true. If it is not, which means that the iteration is still ongoing, we get the value of the top level node or the given node at this point of time and store it in a variable called value to return, which is what we are going to return in the object in its value property. And we are going to return the done false because it is an iteration that is still ongoing. The second important thing we do is that we reset this linked list for iteration object to the next node that is there in the linked list. In our case, we get its access by reading the rest property, and this will continue to keep going on until the rest reaches its end. It is null, and when it is, the iteration will be over. In this way, if we try to iterate over linked list by using for of loop, we are going to be able to see all the nodes values like this, and we can ensure that it is working correctly by also doing the same thing that we had done for the array. We are going to get access of the iterator by calling the symbol.iterator method, and then we are going to keep calling the next method on that iterator, and we are going to continue to keep getting the values that we expect. So let's run this, and we have gotten the values we were expecting. That's it. See you in the next one. Which means that no, that is not what an interface is. Object which has for each there be testing 1 2 3